Welcome to qnawire.
So we first need to find some properties of this wave: period, frequency, wavelength. So we know that the string vibrates through half cycle and then we know that's happening in 4 times and then 1 over 5,000 minutes, because that's the strobe speed. And then at this point, we can say that the period is defined as the time it takes to vibrate through a full cycle. So if we say that this is equal to the half cycle, we can just make a relationship and say that 1 over 2 times t equals 4 over 5,000 minutes. And at this point, we can say that t is going to be equal to 8 over 5,000 and then times 60 seconds over 1 minute. And this is going to be equal to 0.096 seconds. So that's will be the period. Here, the wavelength equals the length of the entire string. So this is simply going to be equal to 0.50 meters. This is going to be equal to the wavelength. And then we can say that the frequency is simply the reciprocal of the period. So it'll be 1 divided by 0.096 seconds, and we have a frequency of 10.4 hertz. So that'll be A. This is the answer for part A. We have the period here, we have the wavelength here, and we have the frequency here. Now they're asking us which harmonic, and it's very obvious to see from the diagram that the string is vibrating in the second harmonic. At this point, it's actually part C is asking us to find the speed of propagation. So we can say that the speed of propagation of this wave equals the wavelength times the frequency. We have both of these values, so we'll have 0.50 meters times 10.4 hertz. And this is going to be equal to 5.2 meters per second. So that would be C. And then D is asking us to find the velocity at position 1 and position 3. So we should first, this is a little bit complicated, a little bit more complicated. So we'll first find the amplitude. We know the amplitude is going to be 1.5 centimeters or 0.015 meters. And we can say that the velocity of y is going to be based on x and t. And this is going to be the partial derivative of the position of y with respect to time. We can also make this is a general equation for y. So y of xt would be equal to 2a sine of kx and then sine of omega t. And k being the wave number. And then we know that Vy, if we're going to differentiate this with respect to t, this entire thing is going to be a constant. So we're really only differentiating this part. So we'll say 2 omega a sine kx and then cosine of omega t. Taking the derivative of sine of omega t will simply be cosine of omega t times omega. So we have that extra omega right here. And at this point, we can say that we're going to have a max when these two are going to be 1. So we can say that Vy max is going to occur, rather it will equal to 2 times omega a. We know that the omega is equal to 2 pi f. So we can make this back into 2 times 2 will be 4 pi f a. So that will be the maximum velocity in the y at any given position. Once we have this, we can simply use this. So Vy at position 1, this is going to be 4 pi f times a, and then at position 1, the amplitude is going to be that full amplitude 1.5 centimeters. So we'll have 4 pi and then 10.4 hertz, and then the amplitude being 0.015 meters. And this is going to give us 1.96 meters per second. So this is position 1. And then Vy for position 3, the amplitude at position 3 is 0. So it's going to be 4 pi 10.4 hertz. But unfortunately, the amplitude is 0 meters. So this will all equal 0 meters per second. So this will be position 3. So this will be your answer to part D. And then it's asking us to find the mass of the string. So the mass of the string is very simple. We can say that V is going to be equal to the square root of the tension in the string divided by mu. And we know that the mu is going to be equal to the linear density, or mass over L, mass over the entire length L. We can substitute the linear density into our velocity equation and say that this is going to be equal to FL over m. We're going to solve for m, and this is going to be equal to FL over v squared. And at this point, we know the force tension in the string, so we'll have m equals 1.00 newtons, and then times the full length of 0.5 meters divided by 5.2 meters per second. And we find that this is going to be equal to 1.85 times 10 to the negative 2 kilograms. So this will be your answer for part E. This is going to be the mass of that string. And that's the end of the solution. Thank you for watching.